welcome to my kitchen again. We are going to be doing our chocolate bar density lab. So I would like you to go to Crooms and you will open up this lab. And again, I'm demoing the lab and you'll follow along with me as I am doing the lab, and you'll be filling out your data table. But today we're going to understand density. Density is a term used to describe the relationship between the mass of an object and its volume. Okay, how much space it takes up and how much stuff is in that space. Okay, normally density, and this is very important, boys and girls, that you remember this, under constant conditions of temperature and pressure, the density of any substance always is constant. It does not change. Altering the temperature and or the pressure of that system that substance might be in can alter the density. So if we have gold and it's normally in a normal type of normal temperature, it's going to have the same density. If we have water and it's under normal pressure and temperature, it's going to have the same density. We're going to prove that today with our chocolate bar. Here I have our little mini Hershey chocolate bar. And the first thing we're going to do is, if you scroll up, we're going to see that density equals mass divided by volume. You're going to watch me do the lab, and you're going to be filling out our data table here. Okay, the first thing we're going to do is we're going to take our chocolate bar, okay. Hopefully I can get it out of the wrapper without it breaking. Okay, and we're going to come over here to our wrapper, because every time we place our chocolate bar on our electronic balance, we are going to subtract the wrapper. So we can see it's 0, 0, and our wrapper is approximately 0.4. Okay, so somewhere on here, just write wrapper 0.4 grams. Okay, so you just always have that as your constant, because when we're doing our mass, you're going to subtract that. So now I'm going to take my chocolate bar and put it on my wrapper, and my mass is 13.4. So everybody here, please write 13.4. Okay, that's for our whole chocolate bar. Next, we're going to figure out our volume. Now, this is pretty much a regular shaped object. Might be a little messed up right there because it was sitting in my car. And we are going to measure, to find the volume of a regular shaped object, it's length times width times height. So we're going to take our length, and I'm just going to do that this way. And of course, we're going to do it in millimeters. Okay. Okay. All right, so I have approximately 6.5. Okay, so we can say 6.5 centimeters. Okay, because we're measuring it in centimeters. All right, so that's our length. Our width going across. Okay. I'm going to say is 3. Okay. Our height, 3 centimeters. Our height is 0.5. Okay, so our height is 0.5. So to find our volume, we're going to take our length, our width, our height. So you have to go back to listen to the video because I forgot those numbers already. Okay, and now you're going to divide your mass by your volume, okay, and come up with your density. Okay, and now you have to, we're going to talk about this in class as we're doing the lab and you're watching it, how to move that decimal point. Okay, since we've already talked about metrics, you're going to figure out which way you're going to be moving that decimal point to figure that out. The next thing we're going to do is we're going to take half the bar. So now I'm going to take half this bar. Okay, I'm going to do the same thing. Put on my wrapper, 0.4, put on my, half my bar is 6.9 grams. Now, same thing, measure my length. My length of my chocolate bar is approximately, I'm going to say 3 centimeters. My width of my chocolate bar We didn't change the width, so that is also 3 centimeters. And my height of my chocolate bar, I did not change, so that is 0.5. So it should be 3 times 3 times 0.5 as far as my finding out my volume, and then we're going to figure out our density. That's the part you're doing on your own. Next we take our bar, we're going to cut it in quarter. Bring it back over, clear this out. Oh, come on. Okay, put on our wrapper. Oh, it's being weird. Okay, put on our wrapper, and it's 3.6. Okay, 3.6. Now we're going to come over here. Again, we're going to write 3.6 for our quarter bar, and we're going to do our length. Our length is approximately 1.5 centimeters. 1.5. Our width is still 3 because we have not changed anything with the width. And our height is still 0.5 because we haven't changed anything with the height. Okay? Again, times your length times width times height. Do your density as mass divided by volume. You're going to figure out which way you're going to do that, change that decimal point. And now we're going to take it and we're going to do it again. And we're going to break our chocolate bar into a little tiny piece. Come back here, put it on, and I have I have 2.0. 2.0. So 2.0 grams. Okay. Again, measure my length. My length is still 1.5. You can see here, 1.5. Now, something changed here. My width changed. So now I'm going to do my width. And I'm going to say that's, I want to make sure I'm lining it up correctly. I'm going to say it's 0.7. Okay, we have our 7 millimeters. Okay, it's 7 millimeters approximately. And then we're going to do our height, which again didn't change, and that's 0.5. All right, so then once we have all our calculations and you've done your density, you should start to notice a pattern. Something should be going off in your head right now, going, oh, Mrs. Harrington, oh my goodness, what did you notice? Did the density change? No, it didn't change. You should have the same exact number running down this column for your density. I'm not going to tell you what that number is because I want you to figure it out. And when we're in class together, then we can talk about it. All right, so once we've done our lab and we've talked a little bit about it, you're going to answer the questions about why is density an important property of matter? Why can we use density to identify certain substances? And that's our lesson on density today, and I hope you have a wonderful day. Bye.